Hi, this video will explain what a capacitor is, why they're so useful, and we're going to go over some common applications for them. On a fundamental level, a capacitor is just a small battery with two distinct differences. Firstly, they have very small capacity compared to regular batteries, and secondly, they charge very quickly. Both of these qualities make them uniquely useful in many electronic circuits. In this circuit, I have set up a 10 volt DC supply in series with a capacitor. I also have a lamp and a resistor, so we can see when the bulb lights we'll know current's flowing. Additionally, I have a switch which swaps between the power supply being connected and the power supply being disconnected. If I first connect the power supply to the circuit, we can see on the voltmeter up here that the voltage across the capacitor climbs slowly to 10 volts. Then, if I swap to removing the supply, you'll notice the capacitor discharges or loses voltage. If I then connect to the supply again, the capacitor charges, then disconnect it, discharges. Now, as I'm charging and discharging the capacitor, take a look at the direction of current flow. You'll notice that when the supply is connected, the current flows in this direction, through the power supply. When the supply is disconnected, the current flows in the reverse direction, both ways temporarily lighting the lamp before it gradually fades. What we're demonstrating here is the way capacitors block DC or direct current when they're in series. When I connect the power supply to the circuit, current does initially flow through the capacitor, but as soon as it's fully charged, current stops flowing. This is why you'll often hear capacitors referred to as DC blocks. What we're doing here when we swap between the connected supply and the disconnected supply is essentially emulating how an AC or alternating current supply works in a capacitor. If we now look at the same circuit, but with a 10 volt peak alternating current supply, we can see that the capacitor regularly charges and discharges, and the bulb flashes on and off, without me having to do anything. In this manner, capacitors in series allow AC to pass freely. This means a capacitor has the ability to remove DC from an AC signal, which is extremely useful throughout many electronic applications. Capacitors also have uses when you have an AC voltage that's been through a diode. In this circuit, I have another 10 volt peak AC supply in series with a diode and a capacitor. If you'd like to know more about diodes, then please see my video on them in the description. A resistor on the end of the circuit is just to simulate a load. Currently, this switch here is not engaged, so the capacitor is not connected. At the top, we can see the green graph, which is this voltage meter over here, which just shows the supply coming in as a sine wave, AC sine wave. As we know, diodes only let current flow in one direction, so when they're connected to an AC supply, we get this effect where we have a sort of half sine wave. You can see the purple line here. This is known as a half-wave rectifier, and I will do a more detailed video on rectifiers in the future. However, if I turn the switch on, thus connecting the capacitor, we can see that the voltage across the load changes, so that instead of dropping back down to 0 volts every cycle, we get this strange rippling effect. The reason this is happening is when the voltage is high, the capacitor charges, and as it drops, the capacitor discharges, thus smoothing out the load wave. This effect is extremely useful and will be covered more in the video on rectifiers in the future. Thanks for watching. Be sure to like the video if you liked it and subscribe if you loved it. Have a good day. See ya!